Welcome to the night class. Today we are going over our Chapter 8 review. Because of the hurricane, we are skipping the first 5 questions where you had to draw the vectors yourself. So you will have probably 5 bonus questions that will look similar to this. We will probably go over and do this one, but I'm going to save it for last, okay? But this is just the force questions like we were doing on Friday, okay? We'll hopefully remember how to do them when we start going over them. So real quick, there's not very many. We'll start at number 6. And all we are doing is writing the ordered pair for the vector and stating what the magnitude is, okay? So for number 6, do a little, all right, so 6, remember, order is important because vectors have what 2 things? Direction and magnitude. Y'all did not say it any like you didn't say it like vector. You didn't do the dance like vector.
Well, you do it.
No. All right. So vector. Okay. Distance and magnitude, or direction. Excuse me. Direction and magnitude. So first, the direction matters. So if it says write the ordered pair that represents CD, okay, vector CD, that means we're starting where?
C.
At C and going to D. So you have to do the D components minus the C components, okay? So very simple, you just make that, it's not a parentheses, it's like a little less than sign. That tells you it's a what? A vector, okay? And you're gonna do the X part minus the X part. So 8 minus 3, and then 16 minus 4. And that is 5 and 12. All there is to that, okay? And then to find the magnitude, you take the square roots of 5 squared plus 12 squared. You use those 2 numbers that you just got, okay? And put them, basically, it's the distance formula, okay? Or Pythagorean theorem, however you want to think about it. So that will be the square root of 169, which is 13.
Okay, so we do change it if you can.
If you can change it or simplify it, yes, you need to change or simplify, okay? If you don't, that'll be 1 point off, okay?
So, I thought the distance point.
You sure?
Yes, sir.
Okay. You sure you're sure?
Wait, I'm sure.
Everybody keep saying that? Never mind.
But what, never mind.
There's no, your daughters look really pretty. They did.
They were, you said something to them about, or maybe you Snapchatted one. Did you Snapchat one of them?
I think I like slid up on somebody.
Or maybe.
Like Kayla.
They told me about it. They were like, Kayla Stringo just messaged me. I was like, oh, that's sweet. Okay, 7. You're like, you know, you're cooler than them, I guess. I don't get it. I'm kidding. All right.
It's probably because they're freshmen.
So, C to D minus the C part. So 5 minus -1 and 13 minus 9. Add those up, 6 and 4. That would be your vector. And then find the magnitude. That was the square root of 52. Is that right?
Yeah.
And 52, I believe, 52 can be reduced, right? 52 would be 2 and 26, and then 2 and 13, so it reduces to 2 square root of 13. I thought they looked pretty, but I'm their dad, so, you know.
It don't count.
They do look pretty.
Yeah, I appreciate it. Thank you. Y'all did too, by the way. 8. 1 minus 3. 10 minus -2. So that would be -2 and 12 would be my vector. The square root of -2 squared plus 12 squared
148.
is 148, and I believe that also is reducible. That'd be 2 and 74, and then 2 will go into 7 3 times 37. 37's prime, so we're done. So you can bring a 2 out front, and you'll have a square root of 37 left. Okay?
You have to have two of the.
You have to have a pair of the same factor, yes, to bring it out front. 12 squared is 144. -2 squared, if you didn't put parentheses around it, it's not going to give it to you the right way. You got to put parentheses around it, okay? You may have got 140. Is that what you got? Yeah, because you must not put parentheses. If you don't put parentheses, it's going to get you, okay? Because that should be +4, and if you don't put parentheses, it's going to give you -4, okay? Everybody good on 6, 7, and 8? Okay, very nice. Very nice. Number 9, 10, and 11 are also very nice. All you're doing is finding vector u, okay? And it tells you what vectors to use, and it gives you the vectors. Here's vector v, here's vector w. Basically, you just plug in and go from there, okay? So this will be vector v is 3, -4, plus vector w is 3, -1. And you do not have to find the magnitude on these, you're just finding the vector. So all you have to do is add up your corresponding parts, x plus x and the y plus the y. So 3 plus 3 is 6, and -4 and -1 make -5. And that's all there is to it. Okay? Any questions? Awesome. 10, same thing, only this time we are subtracting. So 3, -4, minus 3, -1. This is the one where I'm going to do a little work. I'm going to change that negative to a positive and change the signs of the ones behind it. And now it's just an addition one. Okay, so 3 and -3 add up to be 0, and -4 and +1 is -3.
Wait, oh, you already changed.
Okay. 11, same process, a little more work. 3 times v, and then plus 2 times w. All right, so that's going to be, let's see here, 9 and -12. And then 6, not -6, but +6 and -2. And so u, vector u will be 9 plus 6 is 15, and -12 and -2 make -14. Please be careful with your signs, okay? That's really the only thing that I'm worried about tripping you up.
I like those too.
Okay?
Those are nice.
Everybody good on 6 through 11?
Yes, sir.
All right. We are about to do 12, 13, 14, 15, and 16, and it is the exact repeat of this, only rather than having 2 dimensions, we are going to have 3 dimensions. So rather than just having x and y, you will have an x, a y, and a z, okay? But other than that, they're the same problems, okay? So we're literally just doing the same problems over again, but now we have 3 variables, okay? So here for EF, my vector is going to be 7 minus 3, and -1 minus 0, and 2 minus 5. And I simplify that, that will be 4, and -1, and -3. Again, just like we had just finished doing, but with 3 dimensions now. Okay, you find the magnitude the same exact way. You take the square root of 4 squared plus -1 squared plus -3 squared. That equals to the square root
26.
of 26, which cannot be reduced. It can be reduced to 2 and 13, but nothing repeats when you reduce it. So you just leave it as square root of 26.
Say that again, Coach. You said it.
It does reduce. If you can make it go to 2 and 13, but you have to stop there. And since nothing repeats, you just leave it as 26.
Yes, sir.
Okay? Everybody good on 12?
Can you just hold, like, I'm good, I just need you to hold on.
Yep.
Wait.
$13. We have 0 minus 10, and 6 minus 9, and 12 minus 6. Again, just be extra careful. You have to subtract the second point minus the first point, okay? So negative 10, negative 3, and 6. I will know if you subtracted the wrong way because your sign, all your numbers will be right, but every sign will be incorrect. Okay, so don't do that.
Why do you have to do the second one?
Because vectors, unlike when we were just doing segments, because remember, you've done this before, you were just doing it with segments, okay, when you're finding the distance between points, right? The segment, when you were measuring your segment, it didn't matter what direction you were going. You got me? But here, vectors have a magnitude and a what? Direction. Okay, so when you write this vector, it's not just some point, it's telling you where to go. You got me? So you got to have the signs correct. Here, I would go left 10 and then like back. I'm saying my y-axis forward is front, or forward is positive, back is negative. So I would go left 10, back 3, and then up 6. Is that making sense? Okay. And if you did them backwards, you would actually go right 10, right or front 3, and then down 6. So you'd be exactly the opposite place you want to be.
Yes, sir.
Okay. The magnitude, negative 10 squared plus negative 3 squared plus 6 squared, and the square root of that would be the square root of 145, which looks like it should be able to be reduced, but it can't. It cannot. It's like 5 and 29, I think. And so that doesn't help us any. Here we go. The last one, we'll get 3 minus negative 3. Be careful with your signs. 0 minus negative 2. Again, careful with your signs. And 8 minus 1. The reason I said that in first block, I messed this one up because I wasn't careful with my signs. That's going to be 6 and 2 and 7. And so to get the magnitude, we say 6 squared plus 2 squared plus 7 squared. 89, which also is prime. Okay? Everybody good?
Okay, these last 9 have been fantastic.
Aren't they great?
Keep up the trend.
All right. So now we're going to do the plugging in thing. There's only 2 of these, but it's just like we did earlier. We plug in and reduce, okay? So we're going to say 2 times vector W. Vector W is right here. It's 506 minus 5 times V. Vector V is 0, 8, and negative 3. What do you do with those numbers out in the front? Multiply the whole vector by them. So that becomes 10, 0, 12. Watch what I do here. I'm going to multiply everything by what? Then if you multiply by the negative 5, this becomes a positive. You got me? Okay. If you just do the 5, you can keep it as a negative, but don't just keep the 5. Okay. Multiply by the negative 5. So plus 0, negative 40, and positive 15. And then you just add 10 plus 0 is 10. 0, negative 40 is negative 40. And 12 and 15 is 27. And you don't have to find the magnitude on these.
Dang, this lesson's so much easier than I thought it would.
Okay? (16) Same process. 0.25 times vector v is 0, 8, and negative 3, plus 0.4 times vector w is 5, 0, and 6. So 0.25 times 0 is 0. 0.25 times 8 is 2. And 0.25 times negative 3 is negative 0.75. Plus 0.4 times 5 is 2. 0.4 times 0 is 0. And 0.4 times 6 is 2.4. So vector u will equal 0 plus 2 is 2. And 2 plus 0 is also 2. And negative 0.75 plus 2.4 is 1.65. That's what I got as well.
Isn't it the cross products that you do the little thingy that we learn with the matrices?
Yes, we're getting there. All right. Everybody good on 6 through 16? Should be 11 easy problems. Everybody good?
On 12 through 14, do you have with the vector equals?
If you just put the vector, you'll be good. I know what you're trying to find. All right, 17, 18, 19, and 20.
That's where it starts getting new.
Not really. We're finding the inner product and then state whether the vectors are perpendicular. Okay, so first off, when we find an inner product, what type of answer are we going to have? It's just going to be a what?
Number.
A number. One number. If that number is 0, the vectors are what? Perpendicular. If it's not 0, it's not. Easy as that. Okay? So how do we do the inner product or dot product? These are really small, so I got a little room here. I'm going to make them a little bigger. And I don't know why my scan is so blurry. They're not blurry on your sheet, are they? Okay. All right. So here we go. Inner product. You multiply the parts and then do what with them? Add them up. So 6 times negative 1 plus 0 times 7. That is negative 6. Okay?
Oh, 0. Okay.
And if it's negative 6, is that going to be perpendicular? No.
Oh, that's it.
That's it.
Why is that perpendicular?
Because you didn't get what? 0.
It's not.
Correct. 18 is negative 8, 2. Dot product or inner product of 4.5 and 18. Again, don't ever forget dot product, inner product means same thing. Okay? So that's going to be negative 8 times 4.5 plus 2 times 18. What does that equal?
0.
0. How about that? So that one, yes, they are perpendicular. Everybody good?
There was something that was a hard one where you had to do something with matrices.
We're about to.
That's the cross product.
I'm glad you did this, like you're supposed to.
I did, Coach. I was just.
Yeah, because if you had, you would have
You
known.
did give it us.
I know, I did. I'm giving them a hard time.
I completely forgot about it, and then I was in Vodtech, and I was like,
Coach,
shoot,
how
I
does it
have
know
a
you're
test.
talking?
How does it know I'm talking?
It's just talking, bro.
I guess we're all Brian,
Coach,
right?
I was so
just
tired.
boys.
All right. 19, we got negative 2, 4, 8. dots with 16, 4, and 2. So, same type problem, just how many dimensions now? 3 dimensions, but you work it the same way. So -2 times 16 plus 4 times 4 plus 8 times 2.
0.
That all equals 0. So these are perpendicular vectors. $20 is 3, God bless you. 305 times 7, -1, and 2. So that's going to be 3 times 7 plus 0 times -1 plus 5 times 2. 31, which means they are not perpendicular.
So this is it for chapter 8. So all I need to know is how to do the last one.
And the bonus problems.
I feel like the next chapter is having some time.
Oh, random question, guys. Are you still gonna do the makeup test at the end of the?
Yes.
Yeah.
All right. Last two, cross products. Okay. 21, 22, these are the type that Caden was referring to that you have to make the matrix. Okay. What is the answer to these problems? A vector. Okay. If it's an inner product, the answer is just a number. The cross product, the answer is another vector. Okay. You are finding, you got 2 vectors, right? Remember we talked about it? You got 2 vectors and you're finding a third vector that is perpendicular to both of these 2 vectors. You got me? Okay, so your answer is a vector. So I'm going to start off. We'll label this one 21. These are, well, I might can fit them both on here. So this is going to be I, J, K. That is your top row. What do we call those again? I, J, and K are the what vectors? We have a blank circle. Unit circle. These are the unit what? Vector. These are unit vectors. What's the radius of your unit circle? 1. How long or what is the magnitude of your unit vectors? 1. I is 1 in the x direction. J is 1 in the y direction. K is 1 in the z direction. Okay. So there's my unit vectors, and then you just plug in your vectors that you're cross multiplying. So we got 1, -3, and 2, and -2, 1, and -5. And then we basically do the, does anybody remember what this is called? For the matrix, what do we find it basically? The determinant. Close. What is the discriminant? It's the part under the radical in the quadratic formula. Okay, so I used to get them mixed up all the time. So don't feel bad. I'm just glad you knew it was a D. Okay, so determinant is matrices, discriminant is quadratic formula. All right. So if you've forgotten how to do it, you cover up the column that Y is in. I mean, excuse me, not Y, but I. You cover up the column I is in, and what are the numbers that are left? -3, 2, 1, -5. Okay? Very good. You have to subtract the J. Okay? Cover up J's column. We'll have a 1 and a 2, and a -2 and a -5. Plus K. Cover up K's column. We'll have a 1 and a -3, and a -2 and a 1. You sure can.
And this is when you cross multiply.
This is where you cross multiply and what? Subtract.
Like you cross multiply these and then multiply those and subtract.
Correct. Okay.
I wrote it too big.
Please do the review over tonight because it's easy stuff, but it's also pretty easy to forget whether I'm adding or subtracting. Okay.
Did you add and subtract in?
You multiply this times this minus this times this.
Okay, so it's 9.
Okay. Are we good? Melissa, you good?
1 second.
Okay.
Okay.
All right.
Like that.
What's he want to tell us? I've heard this all
Lionel in the Commodore just decided to start playing in my pocket. Why is it? Stop.
I thought that was your ringtone.
No.
I didn't know what was happening.
All right. Sorry, Lionel. All right. -3 times -5 is
Positive 15.
15 minus 2 times 1 is 2.
You said minus?
So it's
Minus.
always subtract on this
It's
part.
always subtract, okay?
You start with the top.
1 times -5 is -5 minus 2 times -2 is -4, okay? 1 times 1, 1 minus -3 times -2 is positive 6. Now, you really don't need your unit vectors anymore because your answer are the numbers, okay? So what number is this?
13.
13. This number is -1, but what's out front here? A negative, so it becomes positive
Oh, I
1.
gotta pay attention to that.
Yes, sir. And then 1 minus 6 is -5.
That will be my downfall on the test, right there.
That is your vector.
So
Now,
that's your IJK.
that, yes, if you wanted to write it as the sum of unit vectors, you would say 13i plus j minus 5k. Okay? Now, do not forget about that part of the problem. It says, then verify that the resulting vector is perpendicular. Okay? How do we know if they're perpendicular?
0.
What has to be 0?
The magnitude.
The inner product has to be 0. So I'm going to come down here.
Wait, we're not done?
No. And we're going to find the inner product of my answer.
Wait, but we've only got one vector.
We have to use the top ones.
We're using the original vectors. We're multiplying. We're doing the inner product of the new vector with the original vector. So 1, -3, and 2.
Why are we doing this?
Because the directions tell me to.
To see if they're like perpendicular or whatever.
Oh, okay.
Okay? See where it says verify? I underlined it right here. Verify if the resulting vector is perpendicular to the given vectors. Okay? It's basically saying, hey, check your answer. In other words. So if I get something besides 0 here, I know something is wrong. You got me? So 13 times 1
Wait, you. I've been waiting for the day we go back to the matrix.
plus 1 times -3 and plus -5 times 2.
I'm gonna take a wild guess that it equals 0.
It should equal 0.
It does.
It does equal 0. So that one checks. Okay? Then you do the same thing with the other vector. So that's going to be 13 times 2 plus 1 times 1 plus -5 times -5.
0.
And 13 times 2 is 26.
13 times -1. Times -2.
Oh, thank you.
13 on your room for 22.
-2. 13 times -2 is -26 plus 1 would be -25 plus 25 is 0. So they both
Next one, just on
work.
our own.
Yeah, try the next one on your own.
Is there a reason why you subtract the J and add the J?
When you're doing matrices, every time it's a square matrix, you always do a positive, then a negative, then a positive, then a negative. So if it was a 4x4 and we started another one, the next one would be -2. Okay? On square matrices, 3x3s, 2x2s. I mean, think about it. When you're doing the 2x2, you're doing this is the positive, and then what do you do with these? You subtract. So it's always the second one is always negative. The fourth one would be negative. The sixth one would be negative. Okay? But we only go to 3 by 3, so you just got to remember that J is negative.
Oh, so you subtract that too. Because,
You're doing this times this minus this times this every time.
so the first one's always positive.
Not necessarily. It could be multiplying two negative or negative and a positive, and the first one's negative.
So why do you subtract the two?
You always subtract.
Oh, you always subtract inside the
Correct. Okay. And Caitlin, I think you put that box for an angel or something in my room. I think you left it, or somebody. Wasn't that in here?
I told you to take it, Kate.
Anyway, it's up there. So if y'all ever want to, make some little kid happy.
Kate, see my text? It's in this.
Has everybody got this copy so I can erase? Because I'm like Clayton. I don't have any room either. I got to erase.
Mine looked identical to yours and like how much room it took up.
Did
So
it?
weird,
How
yeah.
about that?
Negative 54 minus 4. That did not sound good, Clay.
We've been trying.
I know what you said.
Oh wow.
Also, because
I did it too.
also Really? Is that right? I hear you. I hear you, buddy.
Okay. Judging by the volume, I think most of us are close to being done. So for 22, we got IJK again. This time we got 6, 2, and 10, and 4, 1, and 9. So I would have 2, 10, 1, and 9. Negative J would have 6, 10, 4, and 9. And K has 6, and 2, and 4, and 9. Something's wrong. No, that's not 4 and 9. It's 4 and 1. Excuse me. And so you should have had I times, let's see here, 2 times 9 is 18 minus 10. J would be 6 times 9 is 54 minus 10 times 4 is 40. Plus K, 6 times 1 is 6 minus 2 times 4 is 8. And so your vector will be 8. You get 14, but you got the negative out front here, so it's negative 14. And then you got negative 2.
Are you kidding me?
No, I'm dead serious.
Oh, my bad, because now I want to talk to you.
And then we check those. 8, negative 14, negative 2. Inner product with 6, 2, and 10. And we also do the inner product of 8, negative 14, negative 2, and 4, 1, and 9. So,
Oh my gosh.
Oh, you say right there where it says 54 minus 40?
yeah,
Did you say that negative tagged on? So
it does. What's 14? And the negative. Negative 14. 54 minus 40 is 14. Yeah. All right. So 8 times 6 plus, y'all wait, negative 14 times 2 plus negative 2 times 10. Is it 0? Good. And then we have 8 times 4 plus negative 14 times 1 plus negative 2 times 9.
0.
Everybody good?
You still did.
Good. I forgot that.
So, it's your problem.
Huh?
You're
I forgot to
still
check
leaving
today.
it.
Correct. Yes, if you don't get 0, something's wrong. Okay? Now, unfortunately, y'all listen, unfortunately, I have gotten 0, but my vector's still been incorrect before. So,
You just did it wrong?
I guess, I'm thinking it was one of those things that, and it didn't happen all, I think it was one of those things where I checked it just for one of them and got 0 and got lazy and didn't check the other, and that hurt me. So make sure you check both, okay? All right.
I didn't do what you're saying. I get what you're saying. I didn't distribute
We're not doing
it.
it. But you could do it.
So the bonus problem. We did these the other day. They're not. You have 3 forces acting, okay, on an object, all right? It gives you the magnitudes of the forces, and it gives you the angles of the forces. So 70 pounds is acting at 330 degrees, 40 pounds is acting at 45 degrees, and 60 pounds is acting at 135 degrees, respectively. Yes, we did these, okay? Yeah, yeah. So all you have to do, you can't just add up the forces as they are, okay? Because they're going in different directions. So what you have to do is you have to get the components of the forces. You have to get the X part of the force and the Y part of the force, okay? And then you can add all of them up, all right? So, and this is on your formula sheet, but I'm going to write it down here. The X part of your force is always R times the cosine of theta, and the Y part is always R times the sine of theta, okay? Yes, all right? Now, R in your problem, R is radius, right? But we're not talking about a radius. R in your problem is the magnitude. Okay, just remember that. R is the magnitude. Your direction is your theta, is your angle. Okay, so what we have to do, we have to take all 3 of our forces, because we got 3 of them. On Friday, we only worked with 2 at a time. Okay, but this time we got 3 forces. Doesn't matter. You just add the 3rd force. Okay, and you add all the forces up. So the first force, the X part of the force will be R. So the first part is what? What's the magnitude? 70 cosine of 330. Okay. And then 70 sine of 330. That's the Y component. Okay. Of that force. Everybody with me? Plus the second force is how much? 40 pounds cosine of 45 degrees, and then 40 pounds sine of 45 degrees. And then plus the last force is 60 and 135. So 60 cosine of 135, 60 sine of 135. Okay? And in your calculator, you add all that up. So 70 cosine of 330, make sure you close your parentheses, plus 40 cosine of 45, plus, yeah, make sure you, again, close your parentheses because it opens them for you. So you got to close them on your own. Plus 60 cosine of 135. I get 46 point, we'll say 48. Okay? It's 47964.264. So we'll just round to the nearest hundred. Everybody good there?
Wait, Coach Knight, was that all of that in the calculator?
That was this plus this plus this. Okay? Just doing the X parts. Now I'm going to go and do the Y parts. Okay, so Y would be 70 sine of 330 plus 70 sine, or excuse me, not 70, 40 sine of 45 plus 60 sine of 135.
35.7.
35.7.
Are you putting in degrees when you do that, Coach Knight? Does it matter?
Your calculator needs to be in degree mode. Yes, it matters. Okay?
Are you putting a little degree signs with it?
No, I'm not.
Okay, so if you're in degree mode, it doesn't matter?
No, it won't. It won't matter. Okay?
Coach, I got 0 kilowatts.
You should get 35.71.
No, not. Oh. I was only do 2 of them.
Because I have an X and a Y part for each. I did my X's, I added those up, and then I added my Y's.
Oh, I added them together. Never mind.
Okay? Now, after you get this is not your answer. This is just the vector. This is the ordered pair of the answer. Okay? They didn't ask this. It says find the what? Direction and magnitude. So to find the magnitude, we do like we have been doing the whole time. Okay? Magnitude is going to be the square root of 46.48 squared plus 35.71 squared. 58.61. Let me see if that's right.
Yeah, that's what I got.
That's a good sign if most of us are getting the same thing. 58.6. Beautiful. 58.61. And what is that? 58.61 what? Pounds. Okay. 58.61 pounds would be our magnitude because that's what my magnitude was measured in the problem. Okay. Then we have to find the direction, aka the angle. Okay. So theta is the inverse tangent of y over x every time. Again, it's on your formula sheet. Okay. Inverse tangent of y over x. Or you can just remember u rock. Excellent rock. U, y, excellent. U, y over x. Okay, it's tangent. So that's going to be the inverse tangent of, what was the y part in mine? 35.71 divided by 46.48. 37.5 degrees. Did you? You tried to catch yourself, but you didn't. Did y'all hear her question? Coach Knight, isn't this so much better than trig? It is trig. All right. Hope y'all enjoyed the lesson and the review. Study hard. Stay above the line, and we will see you next time.
Andy, you don't joke well.